Okay, so we've been talking about quadratics. And we've got more to say. So specifically, what we ended with last time is we ended with completing the square. And so we're going to do another one of those, but it's going to be the more, pardon me, the more complicated variety. So this is going to be completing the square, but this is going to be the non-monic case. So monic meaning leading coefficient of 1. So here's an example. So solve 3w squared minus 12w minus 17 is equal to 0 by completing the square. So on the one hand, because the instructions say, specifically say do it this way, you've got to do it that way. But even if that part wasn't there, and it just said that, then we've solved equations that look kind of like this before. And the way that we did it is we made a table and we found two numbers whose product is, that one times that one, and then whose sum is that one. And we just sort of searched through the possibilities, and every time that we encountered such a question, it was always possible to find the answer with some integers. That's how we did it previously. But this one, it has solutions, but they're not integers, so you wouldn't be able to find them in that kind of way. All right. So we're going to do it by completing the square. So the first order of business is we'll make a group of the terms that have the variable. So that's the group of terms with the variable. And then that one doesn't have the variable, so it's isolated over there. And then notice that this is not monic. So if we're going to use the technique that we did last time, the technique that we used last time actually depends on it being monic. So then the way that we'll do it is we'll just factor that 3 out. So if we factor the 3 out, then what do I need to write in here? Okay, good. So w squared, and then minus 4w, like that. So now it's monic. So that's good. And now inside of that group, we need to add 0. And we're going to do the same kind of trick as last time, is that we need to add something and also subtract something. So what is it we're going to add and also subtract in here? So it's always of the form plus a fraction. The denominator is always 2, and we're going to square that and then subtract the same thing. So it's always going to look like that, but what goes in the numerator? This number. So negative 4 over 2, that's negative 2, and then when you square it, that's 4. So what we're saying is that we're going to add 4 and then subtract 4. And you know, it's until you get comfortable doing these steps, you might look at this and say, well, you know, that seems weird. We're doing and then undoing it. But the point is that in this group, we started with 2 terms. And now we have 4 terms. So there were 2 terms, and now there's 4 terms. And the 2 new terms have been specially selected so that these 3 terms will factor. So how do they factor? So how does just that factor? Yeah, just negative 2 twice. So it's something squared. Like that. And then now we're going to do several algebraic steps so that we can solve for that that red there. So I'm going to distribute the 3 back in and get 3 w minus 2 squared, subtract 12, subtract 17 equals 0. Adding those constants together is 29, negative 29, and then moving it to the other side, it's 29. So 3 times w minus 2 squared is 29. And then w minus 2 squared is 29 over 3. All right. So, you know, this is sort of like where completing the square is concerned. This is like sort of like what you're aiming for. You're aiming to arrive in this position. And what it's saying, we have an equation now where we're saying, well, we're squaring something and getting 29 over 3. And we discussed this nonlinear equation. So you're squaring something and you're getting a constant. And depending on the constant, the result, there can be 3 different outcomes. So to remind you of the possibilities, squaring, the shape of squaring is a parabola. So the left-hand side, you know, ends up having something that's shaped like a parabola. So if, you know, this question is phrased in terms of w, so over here I'll just say x. So generally it's like x squared is some constant. So 3 parabolas, and then depending on the constant, that determines how the equation will behave. So if c is negative, in the case that c is a negative, then, you know, we'll have this horizontal line, and it'll be down here. And notice that the parabola and the horizontal line don't intersect. If c is 0, we'll have this horizontal line right on top of the x-axis, and these intersect exactly once. And if so c is 0, and for this one c is positive, so something like this. Now there's 2 solutions. So in the question we're working on, which category did we land in of these 3? This one, right? So we're in this one. So, you know, because it says we're squaring something and getting 29 over 3. So there should be 2 different ways to do it. Now, so we want to solve for w. Algebraically, it kind of looks like this. So you could have 29 over 3. And then to solve for w, this squaring needs to move to the other side. And when it moves to the other side, squaring becomes square root. And then what's the left-hand side? Okay, so then this is the most common incorrect response. So I'm not trying to dig on you or anything like that, because there's no points at stake here. But let's look at this for a moment. If this were correct, as written, then how many solutions would there be if this were correct? Just one, right? How many different ways can you solve for w with this written as it is? Just one way. But in fact, we know that there's supposed to be two. So what happens is that you want this square to go to the other side and become square root, but in some sense it can't make it all the way over there, and behind it leaves this this absolute value. So now there's two possibilities. Is that either w minus 2 is negative square root 29 over 3, or w minus 2 is positive square root 29 over 3. So w is 2 minus the square root of 29 over 3, or w is 2 plus the square root of 29 over 3. All right. So, a couple comments are in order, I think. So maybe the first one is that this is really tedious, isn't it? I won't even try to dispute that. It is. But there's gonna be exercises where you've got to do it this way. But that being said, not that many because well, this is a little bit. In the first place, if you do too many of these, you get a hand cramp, right? It's just too much writing. But on the other hand, if you do a lot of these over and over and over again, if you just take this quadratic and solve it by completing the square, and that one, and that one, and that one, and that one, then you start to realize, oh, there is a definite structure to what's going on. I'm doing like the exact same thing over and over again. So by the end of today's today's lecture, we'll extract that whole pattern and say, here it is. Here's exactly what completing the square is, in a very short, concise way. All right. But before we get to that place, we're right on the top of a different, really important idea. So concerning these quadratics. Concerning quadratics, we're going to have factoring, versus solving, versus plotting. All right. So let ax squared plus bx plus c with a not 0 be given, which is just to say, suppose that we have a quadratic. So that this condition a not 0 just means that a can be, the leading coefficient can be a negative number, The leading coefficient can be a positive number, but it just can't be 0, because if it were 0, then we wouldn't have a squaring term. All right. Then the following are equivalent. One, that x minus k is a factor of ax squared plus bx plus c. So it's saying, here's one statement. So, somehow, for some reason, we find out that x minus k is one of the factors. Well, that also means that x equal k is a solution of ax squared plus bx plus c is equal to 0. Now I'm going to write even a third one, but right now understand what it's saying. It's saying that if somehow, given a quadratic, if you can find a factor, then you have also found a solution. And it is also saying that given a quadratic equation, if you can find a solution, then you have also found a factor. So it's saying that these things correspond to each other. And then finally, the point k0 is an x-intercept. Of y is ax squared plus bx plus c. So this first statement is a statement about factoring. The second statement is a statement about solving. And the third statement is a statement about plotting. So what this statement is saying is that these are three different ways to look at the same thing. Now it can feel, I imagine, pretty abstract right now. Probably best to do an example. So here's an example. So please solve x squared minus 6x minus 16 equal to 0. And unlike the first page, on the first page it said solve this quadratic equation by completing the square. This one doesn't say by completing the square. It doesn't specify a method, so you should use whatever method is most convenient. So here's the idea. We want to solve it. But if we ignore the fact that it's an equation for a moment and just look at that, then that's one of those quadratics that's real easy to factor, isn't it? So what if we put on pause the question of trying to solve this? What if we just factor that first? So how does it factor? Yeah. So if we first factor, so sort of like here's in some sense it's like here's the question, and then you say, nope, I'm going to solve a different question. I'm going to factor x squared minus 6x minus 16. This one is easy, right? So x plus 2 multiplied by x minus 8. And then now we can take this back over here and say, ah, yeah, so that's the same thing as doing this. X plus 2 multiplied by x minus 8 is equal to 0. And because these are factors, for example, because x minus 8 is a factor, then what's a solution? X equal 8. So this means that x equal 8 is a solution. These two, those two. And because x plus 2 is a factor, what's a solution? X minus 2. X equal negative 2 is what I meant to say. So those are the solutions. So this is what I'm saying is this over here, this back and forward and back. This is just sort of mentally what's happening. This is the work that you're expected to show. All right. And I'm not really super interested in doing a detailed plot on this particular exercise, so I'll just give you a quick sketch. So what we know about this is we know two things. So specifically, we want to sketch y is x squared minus 6x minus 16. So we know two things. Now, because it's a quadratic, that means that its shape is going to be a parabola. So if it were just x squared like that, y is x squared, then it would be that same parabola that we've plotted so many different times. It would be, if it was just x squared, then it would be one of these. But because these other terms are there, that means that it's been moved around a little bit. But it's still going to be a parabola. It's still going to open up and hold water like a parabola would. But we know two of its x-intercepts. What are going to be its intercepts? Yeah, these two, right? So then, so if I count by twos, and this is 2, 4, 6, 8, and this negative 2, then it would look like this. So negative 2 and positive 8. Those would be the intercepts. And then maybe something like this. So something like that. So to be clear, these three things. So what we're saying is that, for example, on this right side, we're saying that x minus 8 is a factor. X equal 8 is a solution. And the point 8, 0 is an x-intercept. And on the other side, we're saying that x plus 2 is a factor. And x equal negative 2 is a solution. And the point negative 2, 0 is an x-intercept. All saying the same thing. Interesting. So this back and forth, moving back and forth between looking at it from the point of view of factoring, solving, plotting, things like that, it's sort of algebraically comes to a head in a question like this. So, for example, factor 3w squared minus 12w minus 17. So now, that's the same quadratic from the first page. But it's not the same question. The question from the first page was solve this equation. And the question now is factor this expression. So same quadratic. So these questions are definitely similar, but they're not the same. So the request here is to come up with a factorization. All right. So here's the main idea. Is that the request is to factor this thing. So factor 3w squared minus 12w minus 17. And, you know, you can imagine that we're going to perform some work. And then we'll say, you know, something like the factorization is factorization. And then we can write it, you know, in this box. Okay, so that's what we want to do. Now, typically, before, when we were doing this kind of thing, the way that we did this is we did the product sum table. Where you're looking for two numbers whose product is this and whose sum is that. But that's not going to work for this one. So now here's a related question. Solve (3w squared minus 12w minus 17 is equal to 0. And then, you know, we're going to do some work. And then we can say, you know, something like the solution is, and then we can write the solution in this box. You know, the way that we did this on the first page of today is we did it by completing the square. But by the end of the day, we're going to have like a summarized version of completing the square, which is called the quadratic formula. But we haven't said that yet. And these, you know, they're related, but not the same question. So in the end, the way that you navigate this problem is we want to, you know, we're starting here. You know, that's the statement of the question. We want to end here, and the actual path is instead of in some sense going straight here to here, we're actually gonna do this. We're actually gonna go this way, and then this way, and then this way. So that's what we're going to do. It's kind of like you know, you can imagine if you were like carrying a step ladder that's like, you know, like 8 feet wide, you know, 8 feet long, but you're sort of carrying it to width like this so that you're really wide. That's not a very good way to carry a ladder, but you can imagine that you were doing it, and then you try to walk through a door, and then you sort of dink, and you can't make it. So you got to back up a little bit, and then walk in sideways, you know, get in the thing, and then turn back around. So you got to sideways, turn, and then you can continue. So that's what this is that you know, it's sort of like dink, dink, dink. It's not working. So then we have to do this. All right. So here's the idea. You know, from the first page of today, we know that the solutions are w is 2 minus the square root of 29 over 3, or w is 2 plus the square root of 29 over 3. So we know the solutions to that equation. And we can say, therefore, the factorization of 3w squared minus 12w minus 17 will look like this. So now, you know, this remark is saying that a factor x equal k, a solution x equal k corresponds to a factor x minus k. All right. So this should look like w minus, and then I'll make myself a slot to write something in, multiplied by w minus, and another slot to write something in. So it's always w minus slot multiplied by w minus other slot. So this is always minus. Now you might distribute the subtraction and then it later becomes plus, but when it begins it's always minus. So what goes in these slots? The solutions. So, you know, you could say this one in here, this one in here. Doesn't matter which one gets put where. So 2 minus square root 29 over 3, 2 plus square root 29 over 3. All right. So there's something that's not entirely correct yet. There's one thing that's been left off. So let's consider these factors that we've written right here. Now, when we first learned about factoring, back in the good old days when we were only factoring quadratics that factored over the integers and things were nice, right? We could say that, well, you can check the factorization by multiplying out and collecting like terms. And because those numbers are a little bit crazy, that'd be, you know, that'd be a chore, wouldn't it? All right. But nevertheless, in principle, it could be done. And I want you to consider these two factors. So if we were to multiply, so if we multiply out and collect just these, so just the stuff that I'm indicating, then the leading coefficient would be what? So just these. Meaning that what would the coefficient of w squared be? Well, that'd be pardon me, that'd be part of the w term, but not the w squared term. So how can we get w squared? Well, the only way is for this w to multiply by that w, right? So what's the coefficient of this one? 1. And what's the coefficient of that one? 1. And if you multiply them together, what will you have? 1, right? You'd have 1. So that it would look like 1 w squared. So could this be the factorization of that? No, that can't be right, because what's supposed to be the coefficient? It's supposed to be 3, right? But as written, it's 1. So the fix is not difficult. The only difficult part is realizing that there is something to fix. The fix is just, you just got to write that 3. And now it's right. So solving tells you what goes in there, and then you just take a look at that coefficient and you write it there. All right. Interesting. So that's the connection between factoring and solving. So now, if we were, like I said, to do completing the square, like if we had time and we had no possibility of hand cramps and running out of pencil lead and everything, and we just did like 100 complete the square exercises in a row right here, you know, you'd be able to see like, oh, this is the same thing over and over again. And noticing that and turning it into a formula is what's called the quadratic formula. So given ax squared plus bx plus c equals 0 with a not 0. So given a quadratic equation, the solutions are given by the following. Now, before I write that down, I want to point out that we're saying given this equation, the solutions are given by, but understand that the previous remark is also saying something that because solutions are in correspondence to factors, this is also saying something about the factors are given by, and because solutions and factors are in correspondence to x-intercepts, this is also saying that the x-intercepts are given by whatever it is I'm about to write down. So the solutions are given by x is negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. And this symbol right here, plus or minus, is sort of written for purposes of economy, so you can, write a little less. But to understand what it means that there's actually two equations written down here, two possibilities. Once when you write all this stuff down, taking this to be minus, and then again when you write all this stuff down, taking it to be plus. So to be clear, I'll go ahead and do that at least once here. So it's saying that x could be negative b minus the square root of b squared minus 4ac, all of that divided by 2a. And the other possibility is x could be negative b and then plus the square root of b squared minus 4ac, all of that divided by 2a. And this is called the quadratic formula.
Wasn't there like a song or something?
Yeah, there's a song. I would do it for y'all, but we've got to press on. But you could.
I just remember there being a song.
There's several, but it can be sung to the tune of Frere Jacques. It can be sung to the tune of Pop Goes the Weasel, a couple different things. And it's a good idea because here's the deal: is that if you're sitting down for a quiz and the question says more or less you have to use the quadratic formula, and you're sitting there sort of pondering, okay, and then you hear someone going, and then suddenly like, oh, I have it, I have it, so it may be worth your time. Fine. So here's an example of its use. So solve x squared minus 6x minus 16 equal to 0 in two ways. Once by factoring, and then again using the quadratic formula. So we already, we did this one a couple pages ago, and it was straightforward then, and it's just as straightforward now. So if we do it by factoring, then x squared minus 6x minus 16 is 0, and then two numbers whose product is this and whose sum is that. So x plus 2 multiplied by x minus 8 is 0. And so x is negative 2, or x is 8. So not a big deal. So the instructions say do it in two ways. So once with factoring, then once with quadratic formula. So we know that we're going to do the quadratic formula, and this has to be the final part, right? So we know that's got to be the answer. But that's sort of not the point. The point is to go through the mechanics of using the quadratic formula. So the quadratic formula has three inputs in some sense. The inputs are a, b, and c. So in order to use it, you have to identify the values of a, b, and c. So a, b, and c are these coefficients, a x squared plus b x plus c. So for this particular quadratic that we're working on, what is a? It's 1. And b? Negative 6. And c? Negative 16. So we found those numbers, and now you just need to write down the formula. So it's got three different kinds of inputs. A appears in two places, b appears in two places, c in one place. My suggestion for making sure you don't make any errors concerning the order of operations and double and triple negations, making sure you don't get any of that messed up, is that you write down a skeleton of this, and everywhere that you see a letter, like for example that B, you write an empty set of parentheses. So negative, and then slot, plus or minus square root slot squared minus 4 times slot over 2 slot. So my experience is that if you write down a skeleton like this and then just write the formulas inside those parentheses, the probability is quite good that you won't make an arithmetic mistake. But an example of an arithmetic mistake that's made all the time is that here this is negative b, but because b is negative, that's a double negation, and then after that you have another plus or minus, and that collection of negative 6 and then plus or minus and all that seems to throw some people off center. So at any rate, so negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times negative 16 over 2 times 1. So, it's just a matter of some arithmetic there. So that'd be x is the negative 6 becomes 6, and then plus or minus square root. And then if you carefully do that, that's 36 minus negative 64. So 36 plus 64, that's 100 over 2. Of course, the square root of 100 is 10, so this is 6 plus or minus 10 over 2. And now we need to split this into the two possibilities. So it's one possibility is this, when you take the plus or minus to be minus. The other possibility is this, when you take the plus or minus to be plus. So 6 minus 10 over 2, or 6 plus 10 over 2. And so that'd be 6 minus 10 is negative 4 over 2 is negative 2. Or 6 plus 10 is 16 over 2 is 8. So of course that's the exact same answers as these, right? We knew that was going to happen. It had to happen. But you know, this was more work, right? It's sort of like there was a lot of arithmetic. Any question about it? All right, one last one. So here's sort of like a prototypical exercise. So please factor 2 z squared minus 3z minus 11. Just minus 11. And, you know, weeks ago when we first learned about this, factoring non-monic quadratics, we were doing the table thingy, where we say, well, two numbers whose product is this and whose sum is that, and then we, you know, split the middle term and then grouped and all that kind of stuff. That's not going to work here, because this isn't going to work over the integers. So rather than factoring this, we're going to switch. Instead of looking at this from the point of view of factoring, we're going to switch to a different point of view. What point of view?
Quadratic.
Yeah, to solving. So we're going to switch and say, no, I don't like your, momentarily, I don't like your question, I'm going to substitute my own question. So we'll switch, you know, to solving. So we'll say, okay, first I'm going to solve 2z squared minus 3z minus 11 is equal to 0. And then we could use the quadratic formula. So the coefficients that we need are a is 2, b is negative 3, and c is negative 11. So then the formula says that this should be negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times negative 11 over 2 times 2, like that. Now, on these questions, I usually say something like it's not necessary to simplify the radicals because they never really simplify anyway, and it's just sort of besides the point. So this becomes 3 plus or minus, and then the stuff under the radical would be 9 plus 88, so that'd be 97. So square root of 97 over 4. So there are two solutions. They are z is once when you take that expression and take minus. So this would be 3 minus square root 97 over 4, or z is 3 plus square root 97 over 4. And this isn't the answer to the question, because remember the question is factor that. And for the moment we said, no, I substitute, I don't like your question, I'm gonna do my question, do a different question. So these are the solutions. So to get the answer to the question, we say, therefore, 2z squared minus 3z minus 11, its factorization should look like this. It should be z minus a slot to write something in, multiplied by z minus another slot to write something in. And what goes in the slots? These two do, right? Yeah, so these to there. But again, so I'm going to do it in just a moment. But even when I have copied these in there, even when I've done that, it still won't be right yet.
Get out of 2.
Yeah, the 2. And then I know y'all need to go, so you're free to leave, but I'm going to copy this in there. So once all of these things are copied into their spots, that's the answer to the question. All right, so I hope you'll have a wonderful Wednesday.